Thank you very much. I'm going to get set up here. And while I'm doing that, I'd like to, first of all, thank Colorado Mountain College and the team that, Morgan, Calvin. I am an assistant professor in Ag and Resource Economics at Colorado State University. I am in the same department that Calvin is in. I have just started collaborating with Calvin and Morgan on this project. So I'm going to talk to you about regional economic considerations for biofuel and biomass energy production, but I'm also going to talk about some generalities about economics, because again, I'm just beginning to move into this project area, and so I don't have a lot of specific details about the costs, but I have information about economics and general principles of economics that apply to energy. So I kind of think of an economist like a good shortstop. You know, you bring in a shortstop, and sometimes that shortstop covers third base, sometimes covers second base, sometimes plays a shallow left field, but that's kind of a good utility player. That's the way economists are. We come into different projects. I come into several energy projects, and I kind of figure out what models should be used. So that's a little bit of an analogy. But all right, here. A big question in everybody's mind is, when will biomass and biofuels become economically viable on a regional or large-scale basis? And I have 20 minutes to answer that question. So I'm not going to give a thorough answer, but I'm going to give you a simple answer to this complex question. 4 points that I want you to kind of take home. So now, and by the way, I know that probably you've thought about this on an intuitive level. So I'm just going to say it in a more kind of formalized level here. So when will this become economically viable? Number one, when biofuel production costs fall and conventional fuel prices sufficiently rise. Now, what's the dollar amount per barrel? What does oil have to get to? Well, that's not a real direct answer, okay? But I'm hoping that instead of dodging that question, I'm going to maybe deliver some things for you to consider in trying to make these projects viable. But a key thing that I am going to elaborate on is reducing biofuel production costs, because that is the linchpin for everything. You want to increase your profit, reduce your costs. You want to save more money at home? Well, yeah, you could try to get more, you could try to get a raise, or you could try to bring in more revenue. But the real bottom line is you have to control your costs, and that's same for business, and those of you who are in ag, you know what I'm talking about. Okay, now the second thing is that when product attributes are well defined, that sounds kind of like ivory tower-ish. I'm going to elaborate on that a little bit more, okay? Number 3, when markets reflect true environmental costs, like the true cost of carbon emissions. Now this happens to be something that I know a little bit about, and that's where I'm going to deliver some information that you might be interested in, and that's the environmental cost of certain environmental attributes. And that's a lot of what I do as an environmental and an agricultural economist, is I go on to projects and I figure out what the cost is for some of these environmental goods. So I have some information about carbon that I'll share with you. And number 4, you know, when policymakers provide financial incentives to jumpstart the market. I think that's exactly what Morgan and Calvin and John are doing right now. They're using some financial incentives by the means of grants, by the means of education to try to jumpstart this market. Now, as an economist, I happen to believe that the market needs to work for anything to be viable. And I understand right now we're in an experimental phase with the second generation of biofuels. But really what needs to happen is that at a regional level, we need to have people willing to produce it and people willing to use it. And then we will have a market start. And we will have that market gain some traction. So I look at it as the financial incentives jumpstart what we need as like momentum for people growing this stuff and for people using this stuff. I don't think we can plan to become dependent on financial incentives to keep the market going. So let me move into talking about my points. Okay, let me explain this graph for a moment. So I use the analogy that I work on several energy projects and provide analysis on those energy projects. This graph relates to a project that was funded from the Colorado Governor's Energy Office. I was the principal investigator on the project in 2010, looking at the quote-unquote true cost of electricity generation in Colorado. So the values that I came up with were Colorado specific. What I'm trying to show with this graph, again, this is not directly biofuels, but the message applies, is that when you look at the total costs, and that's over here on this y-axis here, the total costs, this is dollars per megawatt hour produced. And when we look at different types of production for electricity, we have what we are typically used to calling the private cost. That's in blue, okay? That's just the input cost, the costs of doing business. Right now, as it stands, for new builds, like new plant builds, wind generation right now has become the most effective private cost of all. So if you look at the blue, that's, you know, again, what we're used to seeing, like the market say your typical private cost. Those are that's the lowest cost industry right there. Right now is wind for new builds. And then we look at, you know, conventional combined cycle, and coal is a little bit higher when it comes to the private costs. Now, my next point, if you remember the previous slide, and I'll just put it up there, when markets reflect true environmental costs, like the cost of carbon emissions, so what I'm talking about are the environmental costs. So putting a dollar value on that, which I have done, you can see that, well, variable power, that's the intermittency of wind. But the environmental cost of some of the other technologies, such as coal or conventional combined cycle, boosts the total costs, but not by that much. Some, but not that much. The bottom line is you've got to be a low-cost producer. So what do I mean by low costs? Well, we talked about, and there were some good questions about that. This gentleman in the front row, you asked about labor costs. As you know, labor is a huge input cost. And so trying to reduce those costs for your biofuels, that's really important. The second thing that's come up, water. Water is expensive in the West, and in Colorado, our water is undervalued. So I have some numbers to kind of talk about that, but the price of water does not reflect the true environmental cost of water. So we want to use low input costs with water. The third thing is transport. Now, transport is, and I think it was John who talked about that. I think Calvin and Morgan also addressed that a little bit. That's where I think on the western slope here, you guys can potentially have a good market for your biofuels, because you might be reducing the transport costs of getting other products, other energy products from other parts of Colorado or, or Wyoming. Now let's face it, at the moment, coal is also fairly inexpensive to transport. And that's where some of the environmental cost factors may come in and make that difference, make that marginal difference, kind of like you see right here. Okay, so let me move on to the next more mysterious category, which I said, defining product attributes. I'm going to use an example of biochar. Now, we haven't talked about biochar much today, and I'm going to defer to the people with the really good biochemistry backgrounds for real specific questions on biochar. I know that Morgan has a really big hand in the biochar. It's basically charcoal. And it's being proposed as a good way to retain carbon in the soils. And it's interesting because a lot of people are hearing about biochar and that it's a very good solution for maintaining the carbon in the soils. But here's a little bit of the complexity when we go about an economic study. We I've been asked a lot, okay, so how much would it cost me as an agricultural producer to put this biochar in my soil, and what would be the benefits? Well, the problem is that we don't have the information to answer that question. Because when I look at price information, and a lot of this has come from the hard work of my graduate research assistant, Ms. Greta Lohman, who's a PhD student. She's sitting up here up front, so a lot of her work has gone into this. But what we found is that the largest purchaser of biochar, it's the researchers. So when we look at the price, it doesn't really tell us what you would pay for it, because the BLM, the Forest Service, and Flux Farms, you know, are the biggest, that's the biggest demand side. Now, in terms of supply, we don't have a well-defined product because there's different inputs. So we visited some really good folks in Golden, BEC. They have pine beetle as an input, you know, where they use that to make the char. They also have peanut husks, peanut shells. They get inputs from all over the nation, really, being brought in by rail. And so it's difficult to control what the output is, what the product is. And so the bioscience is also not fully there yet. And what that means is that, you know, people like Calvin, like Morgan, they're trying to define the interaction between the soil type and, you know, the interaction between the soil type and the char products with these different inputs, whether it's pine or peanuts. There's not a systematic relationship. So if that soil's Minnesota soil, or if it's from the shortgrass steppe in eastern Colorado, we don't have well-defined parameters on that. And like I said, we don't have well-defined prices either. And so that's the kind of a difficulty that we run into when we're working with something like biofuels. And people say to me, well, how much would it cost for this, or how much would it cost for that? What I have to do is model it on a spreadsheet, knowing that my numbers are somewhat in a vacuum. But the numbers I provide at least can inform you whether or not that's a risk you want to take. And so we have this sort of symbiotic relationship where in the research lab we can at least put together some probabilities and some prices, knowing that we can at least provide you some information, but a lot of the risk will be borne by you. However, as an economist, that's how markets form. And I would encourage, you know, I wouldn't let that scare you away. I would let you look for that information to inform you of the decision you want to make. I'm going to just elaborate a little bit about the biochar example. You know, we've got inconsistent sales prices, inconsistent production costs, and volumes sold. Some suppliers give away char. So I think I mean, I wouldn't be surprised if some, you know, a lot of the inputs that are being received, you know, have been, for the current research, are being done by a grant. But for this market to develop, it's going to be on us as a regional economy to really make it move. It's difficult in this case to predict future demand. This is sort of like just a tie-up. The next step in our biochar market study, Greta's looking in nurseries in Hawaii, because there's not really a demand that we found here in Colorado outside the research. Oh, I'm going backwards. Okay, outside the research network. All right, so let me move to my third point, putting a price on environmental attributes. So a lot of the research I do puts a price on harmful or good environmental attributes where there's not currently a market. And so I'm going to give you the example of carbon, because carbon will be a linchpin, I think, in starting this market. But if you're relying on a carbon market to form to determine whether you're going to be profitable, I believe that's the wrong strategy. Now, let me summarize this slide.